Welcome to our series of geotechnical engineering. Today we will study compaction of soil. So let's start. Now, stabilization of soil increases its engineering properties. Like methods of stabilization, there are mechanical methods, chemical method and soil replacement methods. We already know. Mostly mechanical methods adopted. In mechanical methods, most simplest is compaction. Now, compaction, that is artificial rearrangement of soil particles such that void's volume will decrease, so the packing will increase. So our main principle in the compaction is reducing the void's volume, so the packing will increase, the soil will become denser and more stable. Compaction can be dynamic or static. Dynamic means repeated compaction by dead load, that is more applicable in case of coarse grain soil. Static compaction means increase in static load. It is applicable more in fine grain soils. Degree of compaction is expressed in terms of dry unit weight of soil. The amount of soil solids that can be packed in a unit of volume of soil is called degree of compaction. Now we have to look at the two processes. One is consolidation, second is compaction. Now consolidation is time dependent process. It takes long time. In consolidation, soil is completely saturated. In consolidation, volume decreases because pore water goes out from voids. In consolidation, when a load placed on soil for a long time, consolidation happens over a long period of time. Now look at compaction. Compaction is instantaneous process. It takes less time. In compaction, soil is always unsaturated. In compaction, volume decreases because at a given water content, air in voids gets out. In compaction, when a load applied on soil for short time, then the compaction will happen. So we have look at some differences, common differences among the consolidation and compaction. Consolidation is time dependent, compaction is instantaneous. In consolidation, soil is completely saturated. In compaction, soil is always unsaturated. In the consolidation, the volume reduction happens due to the pore water goes out from the soil. In compaction, the pore air goes out from the soil. And compaction happens when a load is applied on soil for short period of time, while in case of consolidation, load placed on soil for long time. Now advantage of compaction. So the shear strength will increase, bearing capacity of soil will increase, compressibility, permeability of soil will decrease, bearing capacity of subgrade soil will increase, settlements, volume changes prevented, swell and shrink also prevented. So these are all the advantages of compaction. Now heavily compacted soils show decrease in shear strength. So compaction is good, but only up to a certain limit. After it, the shear strength will decrease. So over compaction is not good. Now compaction in laboratory is measured by standard Proctor test, that is called SPT, then modified Proctor test, that is called MPT, then there is Indian standard equivalent of SPT, that is light compaction test, and then finally Indian standard equivalent MPT, that is heavy compaction test. So we will look all these one by one. So first is SPT. In this, mold volume is 1/30 cubic feet, that is 944 centimeter cube. In this mold, the soil is filled in 3 layers. Each layer is compacted 25 times. The standard hammer weight is of 5.5 pound, that is 2.495 kg. The hammer dropped from a height of 12 inches, that is 304.8 mm. And the relation used is gamma D, dry unit weight, is equal to bulk unit weight divided by 1 plus water content. So repeat this test with different water contents, compaction curve drawn, that is gamma D versus water content graph. Peak of this curve correspond to maximum dry unit weight and optimum moisture content. Generally, dry unit weight maximum ranges from 16 to 20 kilonewton per meter cube for most of the soil. In exceptional cases, the range goes from 13 to 24 kilonewton per meter cube. Similarly, for most of the soils, the water content, optimum moisture content range goes from 10 to 20%. In exceptional cases, it goes from 5 to 30%. Dry unit weight maximum is correspond to the compaction effort in lab. So same dry unit weight maximum can't be promised in field. Means in the lab we do the compaction very well, but in the field same kind of sincerity, diligence can't be promised. So the same degree of compaction will not be achieved in the field. Now the second, now this is the curve which we studied. On the y-axis we plotted the gamma D, dry unit weight. On the x-axis we plotted the water content. Now we change the moisture content of the soil sample and test the dry unit weight. Each time we plot a graph of it like this. Now this graph has a top point like this. Corresponding to the top point there will be a dry unit weight and there will be a moisture content. So corresponding to the top point of the graph, the dry weight will be gamma D, maximum dry unit weight, and the water content will be optimum moisture content. Optimum moisture content means that moisture content at which we get the gamma D maximum. There is also a zero void line here. All the curves will be to the left hand side of this zero void line, sorry. And this zero void line means 100% degree of saturation line. Now the second test is MPT, which is modified Proctor test. In this test the mold volume is 1/30 cubic feet, filled in 5 layers, each compacted 25 times. Standard hammer weight is 10 pound, which is 4.54 kg. Hammer drop height is 18 inches, which is 457.2 mm, and the procedure will be same. Then the next is IS equivalent SPT, that is light compaction test. In this the mold volume is 1000 centimeter cube, filled in 3 layers, each layer given 25 blows. Standard hammer weight is 2.6 kg and the drop height of hammer is 310 mm. The next test is IS equivalent MPT, that is heavy compaction test. In this the mold volume is 1000 centimeter cube, filled in 5 layers, each compacted with 25 blows. Standard hammer weight is 4.9 kg and hammer drop height is 450 mm. Now compaction effort or compactive energy. So we take the mold, then we fill the soil in it in layers 1, 2, 3 after giving compaction to each layer. Then we get this type of ready sample, then we remove the mold, we get the soil sample, we measure its unit weight. So we know the bulk unit weight, we know the moisture content. So by this formula we get its dry unit weight. We change the moisture content, again we fill the mold in 3 layers or 5 layers, whatever is mentioned in the method. Then again we will use this formula, then again we'll receive the gamma D, then again we will change the moisture content, do the compaction, and again we'll find the gamma D. So by changing the moisture content we will keep finding the gamma D repeatedly to make a plot of Now the compaction is affected by the degree of compactive effort that you have put onto the specimen. Like how much you have compacted this layer, how much you have compacted to this layer, how much compaction you have done to this layer. So this whole compaction which you have done onto the specimen can be summed up as compaction effort, means the energy you have put onto the sample to compact it, which is called compactive energy or compaction effort. So compaction effort is denoted by capital E and can be found by E equal to N. Here N will be the number of layers of the soil into the mold. Then capital N means number of blows per layer. Then capital W, that means weight of the hammer. Then small h, that is drop height of hammer, and then divided by volume of mold. So by this we can get the compactive effort. Now zero void line. So zero void line is gamma D correspond to 100% degree of saturation will give us the zero void line, steadily decreasing line, and gamma D 0 is equal to gamma W divided by 1 upon Gs plus W, water content. By using this relation you will get this formula. Now factors affecting compaction. First is the water content, as dry unit weight is directly proportional to the degree of saturation. Second is E, compactive effort, as E is inversely proportional to the water content and E is directly proportional to the unit dry weight. Then soil type, well graded soil have more compaction and poorly graded soil will have the lower compaction. Also method of compaction, like what method you are using, rammer, rollers or vibrators, so that will decide the compaction level. Now compaction behavior of sand. So if you plot on y direction the dry unit weight and on x axis you plot water content, so for sands you will find out that first the dry unit weight will start to decrease as you increase the water content, then suddenly it will start increasing and then again start falling. So this kind of behavior you will find in soils which are in category of sand. Now in case of sand you will find this position is air dry, means here the sand was air dried, then we start increasing the water content. So initially the unit weight dry will decrease, reaches a minimum point, and at the point where the dry unit weight is minimum on increasing the water content, that point is called point of maximum bulking. Bulking means the sand particle will attract water around it, so there will be maximum distance between two sand particles because there is water between them, so the volume of the sand will increase suddenly, and this increased volume will be due to the water inside the pores. So and then again the unit weight will start to increase suddenly, reaches to a full saturation point and then again start falling down. So this is the behavior of the sand as we increase the water content. So initially water content increases, the gamma d decreases due to capillary tension of pore water. This is called bulking of sand. Maximum bulking of sand happens at 4 to 5% of water content. Now gamma d will increase beyond this point. At degree of saturation 100%, the gamma d will be maximum. After degree of saturation 100, the gamma d again will start to decrease. So this is the behavior of the sand. Now evaluation of compaction by relative compaction. So in the lab you have gained suppose this much of compaction, but in the field you will reach up to only this much compaction. So how we can relate the in lab compaction to the in ground compaction, or in field compaction? So field compaction, so dry unit weight in field divided by dry unit weight maximum in lab into 100 will give us the relative compaction. Now field compaction equipments. So there are some static pressure equipments like rollers, then there are impact compaction equipments such as rammers, then there are vibration compaction equipments such as vibrators. So if we have a confined area, then for all kind of soils we can use rammers or dampers. If we have to construct a road, for road construction, and the soil is crushed rocks or gravels or sands, then we can use a smooth wheel roller. If we are working on base or sub base embankment for highway, airfield or earthen dam, and the soil is sand, gravel, silts or clay, then we can use pneumatic tired rollers. If we are working for core of earth dam and the soil is clay, then we can use sheep foot roller. If we are working on embankment for oil storage tank and the sand and the soil is sand, then we can use vibratory rollers. The next topic is 1D compaction, settlement during compaction. So suppose this is our initial soil mass having the three-phase diagram. Now after the compaction some height will decrease, which is denoted by delta H. So the total height was capital H. The height of voids including the volume of air and water is HV1, and the height of the solids is HS. After the compaction the reduction in height is delta H, and after the compaction the height of the voids is HV2 and the height of the solid is HS. So HS will remain the same and the height of voids will change, and because there is reduction in the height of the voids. Now we know void ratio is volume of voids upon volume of solid, so that will roughly equal to height of the voids upon height of the solids. Now using this relation we will get E naught will be HV1 upon HS, which will give us the HV1 equal to E naught HS. Similarly HV2 will be equal to EF into HS. Now delta H is equal to HV1 minus HV2, that is E naught minus EF into HS. Now we know H is equal to Hs plus Hv1, so we will get delta H upon H equal to E naught Hs upon H, like given here in formula. Delta H upon H will be equal to E naught Hs upon H minus Ef Hs upon H. Now delta H will be equal to E naught minus Ef divided by 1 plus E naught into H. So by this we can find the reduction in the height of a soil layer due to the compaction. So that's all for this video. In this video we have covered 1D compaction, settlement during compaction, field compaction equipments, compaction behavior of sand, zero void line, factors affecting compaction, compaction effort, and various tests for measuring the compaction. That's all for this video. Thank you.